This video will walk through how to complete labs 8 and 9 for hydrology. We're going to start by going to the hydrologic modeling wizard. We need to save our project. I've already chosen a file path and named my project lab 9. I'll press save and overwrite that. Next, we need to pick project boundaries. This lab is for Dry Canyon in Logan, Utah, so we're going to use UTM Zone 12N. You find that under Global Projections, and then you go to Projected Coordinate Systems, UTM NAD 1983, and then find Zone 12N, and press OK. And you want to make sure that your vertical units are listed as meters, and press OK again. Next, you need to define a project boundary. I've already got the map zoomed to Dry Canyon, but if you are not already there, you can search for Logan, Utah. And the pin will put you right in the middle of Logan. Pan over towards Dry Canyon and zoom in. You can use the zoom controls and resize your window until you fit the watershed neatly within the map area, and then you can press OK. And then I'm going to come to next. We'll be using web services to get our data. And then you're going to need to check all of the data sources that we need to build an HEC1 model. The first two that I've clicked are imagery. They're base maps. These are optional. But if you scroll down, you're going to need the worldwide elevation data, the National Land Cover database, and I've checked 2011. And then you'll also need the Surgo soil data. After you've checked all those boxes, you can press download, and it will ask you what resolution to download all of these in. You can accept the defaults. When you get prompted to choose the resolution for your watershed, the DEM, you can pick 12 or 13. That would be about 30 meters or about 15 meters. I'll pick 15 and press OK. And that one's asking me the resolution for the National Land Cover data sets, and now it's getting the Surgo shapefile data as well. All right, when that's done, you can press next, and we're going to need to compute flow directions and accumulations so we can delineate a watershed. So press compute topaz, and you can enter a flow accumulation threshold of about 1/4 mile squared and press apply to display. Now you're going to need to enter the outlet location for the watershed. So I'll drop a point roughly around the outlets. You can use the imagery base map if you need some help finding the outlet. And then press next and press delineate. This shouldn't take too long, and when it's done, you'll be able to see the area of the watershed. You should get something right about in the neighborhood of 3.5 square miles. I have 3.54, so that looks okay. Then I'll go next. We're going to be building an HEC1 model, so make sure that that's selected and then press initialize model data. Nothing will happen on this menu, but it will work if you press initialize model data. Next, we need to do job control. We're going to run a 36-hour simulation, so I'll leave the dates as is. This date doesn't affect anything, only the duration matters from these date and time inputs. So I'll choose 12 a.m. there we go, on March 3rd, and I'll go until the following day at 12 p.m. That should be 36 hours. And you can leave the time interval at 10 minutes. After you've put all this in, make sure you press set job control data so that it gets applied to the model that we're building. Now we can move on and press next. Now we need to define the soil type data using the shapefiles to create a coverage. Remember, coverages are what WMS uses to combine GIS data and all the supplemental information that you provide so that it can be used to build a model. First, we need to join NRCS data for both of the shapefiles that I have downloaded, and this is what adds the attributes to the table, or the columns to the attribute table of these shapefiles, so that they have the hydrologic soil group property, which you need for the curve number loss method. So after you've joined those tables, you can press create coverages, and it's going to say we want to create a soil type coverage. That's good. And the shape files that we want to use are these soil shape files. Make sure they're both checked. You can press next, and then it will ask you to confirm that all of the attributes are there. If you've pressed the join NRCS button, this should all work appropriately, but you can skim through and make sure. Then press next and finish. All right, now if I look over at the Project Explorer on the left, I have a drainage coverage. That's what has my delineated watershed boundaries in it and properties like the area and slope. I have the soil type coverage. This is the one we just created with the shapefiles. And we also need the land use data. And since we downloaded a gridded land cover database file, this came in as a grid, so it shows up under a grids subdirectory rather than under coverages, but this is correct. Now I can continue on. First, we're going to need to compute a curve number. To do that, we're going to come to the top button for Compute GIS Attributes and make sure that what we're computing is SES curve number. We'll use the soil type coverage for soil information. We'll use a grid, in this case the National Land Cover Database grid, for determining land use. And now we need a mapping table. This is what relates the combinations of land use and soil types to curve numbers. Your assignment for Lab 8 was to come up with that table, and I showed you that if you press this help button, it'll take you to a Aquaveo help site, or you can download a starter. I'm using the 2011 National Land Cover Database, but you can use this 2015 table also as a reference. For demonstration purposes, will be close enough. I'll press right-click and press Save As. And this takes me to the place I want to save it in my folder for this lab. You can leave the name as is or change it to whatever you'd like. Now I can go back to WMS and use the Import button to open that table. You can verify that it opens appropriately using the preview here, and then press OK, and it will generate a curve number report. You can skim through here and see the land use and hydrologic soil groups that it mapped to your dry canyon watershed and see the weighted average computations that it does. I got 76 for my curve number. It shows a lot of decimal places, but that's not really necessary. You can round this to 75 or 76. All right, now I need to build the rest of my HEC model parameters. Oh, and there's a bug. If you press Edit Parameters and all of these buttons are grayed out, you can go back to Select Model and reinitialize your HEC1 model. And this time, instead of using the menu on the left to jump to hydrologic computations, use the Next button. And this time, when you press Edit Parameters, it will work for you. Now, the basin data is already populated for you using the delineated watershed. The output control is also appropriate as is. You don't need to change anything here. We are going to enter precipitation, losses, and unit hydrograph data. First, precipitation. We're going to use basin average precipitation, and you can press Define Series, and it will open up this menu where you can copy and paste the time series that you generated in Lab 7. I'll go open up Excel, and this is one of the spreadsheets that you should have downloaded to create the SCS storm distributions. And you'll notice that this is given in hours, but WMS wants your time in minutes. So I'll do some conversions, multiply this times 60. And I'll use about 4 inches of depth, since that's approximately the 100-year storm depth for a 24-hour storm at Dry Canyon. And to do that, I'll multiply the type 2 distribution values times my depth of 4 inches. And then I can copy these all the way down, and then copy the columns with minutes and my depths. Select both columns in WMS and paste them in. I can preview that this looks correct. If this does not look right, then you probably copied something in wrong. So go back and check. When you're done, you can press OK and press OK again. For the loss method information, since we just computed a curve number, this should auto-populate. If, for example, you have not finished Lab 8 yet and want to get a head start on Lab 9, you can manually enter in a value here. Like for instance, I'll change this to 74 just to demonstrate and press OK. Now we need to enter some unit hydrograph methods. We will be using the Clark unit hydrograph. And for this, you need a time of concentration and an R value. To fill those in, you can use the Compute Parameters Basin Data menu that's on the bottom right. And the Lab 9 instructions tell you to use the SCS lag time method. You should get a lag time of about 0.6 hours and an R of about 1.6, 1.7 hours. But this depends on your curve number. If you come down here, you can see that the curve number is one of the variables used to empirically estimate what the Clark's R coefficient is. So depending on what your curve number is and exactly the size of your watershed and some of those things, your R value could be different. That's okay. But I've got this done, so I'll press OK, and those will populate up here. All right, and that's everything. We are not doing anything to simulate snowmelt for this model, so I can press Done and press Next. We've already defined precipitation, so you can skip over this part and skip past the cleanup model for now. And we're on to Run Hydrologic Model. So an HEC1 model saves input data, outputs, and solutions in 3 different text files. It's really convenient for you to save them all with the same file name prefix. So for instance, I could change mine to SCS type 2 and press update file names, and then the files that WMS will create for me will all have the same prefix. I recommend you do that. Once you've chosen a file name you like, you can press Run Simulation. It should not take very long to run, and so you can press Close when that's finished, and you can also close out of the Hydrologic Modeling Wizard. Now that we've finished the simulation, we've produced some direct runoff hydrographs, and we can see that there's an icon for that above the outlet and in the middle of the watershed. If I click on use this Select Hydrograph tool that's on the left of my map, I can then double click on the hydrograph and the plot will open up for me. You're going to need to save a bunch of these and generate some other graphs for your report. To do that, you can right click on the graph and press View Values, and then you can copy and paste these columns into Excel so that you can save them and refer to them again later. And that's the general process that you'll follow for Lab 9. You'll need to repeat this for each of the other models or each of the other hydrographs that you're asked to create. And you'll just come back to the HEC1 menu using Edit Parameters here, and then replace the precipitation data with the data that the lab asks for.